Hi, I'm Amanda Jones, and this is the third video in a series of videos about fractions. And this one is about subtracting fractions. I have some examples up here, and I'm using Mathagons Polypad, which will help us model our fractions. And so this first one up here is 5/9 minus 3/9. And this is an example with a common denominator, same denominator of 9. What's nice about this is that if you think about a pizza, it's been cut into the same number of pieces. So if you think about what that numerator is and what that denominator is, I have 5 pieces of a pizza cut into ninths. Okay, and I'm going to eat or remove 3 of those pieces of the pizza that's been cut into ninths. So that's not too bad. I can model that with ninths. So I'll pull up my ninths here, and I need 5 of them. So you can see this. This is these are ninths, and I've got 5 of them. And of course, that 9 represents how many pieces the whole has been cut into. And so if I wanted to complete that circle, I would need 9 pieces. But I have 5 of those 9 pieces, and I need to remove 3 of them. Okay, so I'm just going to split this. I'm going to take away 1, 2, 3 of them, and I'm going to see that 3/9 right there, and then I'm going to delete it because they're gone. And what am I left with? I'm left with 2 pieces of a pizza that's been cut into ninths. I am left with 2/9. All right, simple enough. Now things get a little bit more complex when we have unlike denominators, like 4/5 minus 1/2. So let's model this. Let's get our 4/5 here. Okay, 4 pieces of a pizza that's been cut into 5 pieces, and you can see that it would take 5 pieces to complete the whole. All right, we want to remove half of it, wait, I don't even see the half here. You know, if I took away, for instance, if I split this and just took away these 2 pieces here, you can see that's not half. I mean, that's half of what I've got left, but that's not half of a pizza that I'm removing. I want to eat half a pizza. And so how are we going to get to where we can remove a half? Now, sometimes I like to pull up a half just next to it so that I can visually see what it looks like. So again, just really being able to see that these 2/5, okay, would not be a half. All right, we've got some pieces, something missing there. And so I'm not able to remove a half unless I start cutting this pizza into more pieces. And so that's what I need to do. And so I will start renaming these. I'll merge them back together and start renaming them into something that I could perhaps find a half of. So hopefully some of you will probably go ahead and see that half now that has formed right here. Okay, but some of you may not see that, or there might be a problem where it's not as easy to see a half. And so another thing that you can do is start looking at your half and renaming it until you can see that equivalent fraction of 5/10. Okay, so renaming it until you get that denominator the same. And you've always been told you need common denominators to add and subtract fractions. This is why we've got to cut that whole into the same number of pieces, which is what I like to say, is that we've got to get it cut into the same number of pieces. Otherwise, we don't know how to remove, like how to orient it, how to remove the right number of pieces. Okay, this is what it would be with if I had my kids, if I had 4/5 of a pizza left, it's to have to start cutting those pieces into more pieces in order to really see those halves, that half of a pizza, to be able to split it in some way, not into, I don't know, to see the 2 halves here. Okay, so now you can see that 1/2 is equal to 5/10 And so you're rewriting, you can rewrite that as well. So now instead of 4/5, you have 8/10. Okay, so you can count those 8/10 there. And you also, that 4/5, you want to see that again. Let's go back to those 4 pieces. Right there, they are. And so what you did is you split each of those fifths into 2 pieces. So you multiplied your 5 by 2. And when you did that, you also needed to multiply your 4 by 2 to figure out now how many pieces that we have. And so now we've got 8/10 instead of 4/5. Those are equivalent fractions. I didn't change the shape of that. I just renamed it. Okay. Same thing over here with the half. I didn't change the shape of it. You can still clearly see that one. It's a half. And so I can see that it has now 5 pieces of a pizza that's been cut into 10 total pieces. And so that half has been cut, that 2 has been cut into 5 pieces. So now I have 2 times 5, which means that I've got to multiply by 5 up here as well to see how many pieces that I have. All right, so you have 8/10, or they're the same. 4/5 minus 1/2, it's the same as saying 8/10 minus 5/10, okay? And so now I'm going to delete this, and I'm going to remove 5/10. Split these. 1, 2, 3, 4, 5. Delete them. And what do we have left? We have 3/10. And that is what 8 minus 5 is. It's 3. And we're still in tenths. Our denominator is tenths because we've cut that original whole into 10 pieces. All right, one more. 7/12 minus 1/4. Okay, so I'm going to get my twelfths. And count 7 of them. Okay, so that's 7/12. And I'm removing 1/4 of these. 1/4 from this. So 1/4 of a whole from the 7/12. I'm getting into multiplication when I'm thinking about 1/4 of that. This is not multiplication. This is, we are taking 1/4 of the whole from the 7/12. So it's basically saying I have 7/12 of a pizza. I want to eat 1/4 of a pizza. I'm going to remove that. Now, how much of the pizza do I have left? So there's some practical terms there that'll hopefully help you see that. So it is confusing to think about 1/4 of the 7/12. That's not what we're doing. Okay, we're removing 1/4 of the pizza, or 1/4 of pizza. All right, so we've got 7/12 here. I'm going to put 1/4 next to it to kind of see it next to it. What's cool here is that I can rotate this, and we actually have, like, I can put this right over here. You can see that. You see how it snapped in there? I'll do that again. Right on those lines, snapped to it. And that's because 12 is divisible by 4. So we can see that 1/4 there. So, I mean, honestly, you could just split this and remove that 1/4. Okay, and see, you can see, I'll do it on top of it too. And see how that is 1/4. It covers it all up. It's the same. And we can also take those 3/12 and merge them together. Okay. And you can see there that they're equal. You can also rename that back into that 1/4. So you see that you really have removed 1/4 of that. Okay. From that 12. You can also, let me go back to this. Okay, you can also look at your fourths and keep on renaming and see that 1/4 is the same as 3/12. So several different ways to look at that. Hopefully that helped you see all the different ways to show how 1/4 is equal to this 3/12. Okay, and so I've renamed that kind of back to the way I said it in the other problem. I've renamed that 1/4 into 12 so that you can see how many pieces we need to remove. I didn't have to do anything with the 12ths this time, and you don't always have to. So you don't always have to multiply those denominators together. I know that that's sometimes how we're taught. Is just take it and do 12 times 4 and you've got 48. But why would I want to deal with a whole that's been cut into 48 pieces when I can deal with a whole that's been cut into 12 pieces? So smaller numbers are going to be easier to work with, less chance of mistake. And so I would always recommend that you're looking for a least common multiple. You're not always multiplying them together. So 12 times 4 would get you to 48. But the least common multiple between 12 and 4 is 12. And so it's so much easier to just change 4 to 12ths instead of changing both of them into 48ths. Okay, so that is what we did. We just simply took those 4ths and changed them to 12ths. In doing so, I needed to cut that 4th into 3 pieces. So my whole, if you think about all 4 of the 4ths, had to be cut into 3 pieces. Each 4th had to be cut into 3 pieces. So I have 4 times 3, which is 12 pieces. And then because of that, I've got 1, 2, 3 that my 1 has been cut into. So that 1/4 becomes the 3/12. So this one didn't have to be renamed. The 7/12 stayed as it was, but the other one needs to be renamed into 3/12. Okay, and we can see that. We can do that removal. Take those 3/12 away and count how many we have left, and we have 4/12. But you might notice that that might not be the simplest term, so we always need to check that. If you don't notice, check it and merge these and see if there's some renaming that can happen. There you go, that got a little simpler, and it's 3/9, and it can actually get even more simplified into 2/6, and then and even more simplified into the 1/3, so down into the 1/3 unit fraction. And 4/12 is equal to 1/3. So that is our final answer here. Okay, I hope that was helpful and that modeling these fractions helped and that you're able to replicate this on your own. Thank you.